Okay, so what we're going to look at now are limits that you can evaluate, but you may have to do some factoring first. So let's look at an example. The limit as x approaches 0 of x squared plus 2x over x. So the first thing I do is I always try to plug 0 in, or whatever the value is. But if I try to plug 0 in here, I get 0 over 0, which I can't have 0 in the denominator, so that doesn't work. So then my next step is to try some algebra. And if you notice, each of these has an x, so I can actually factor that out, take out that greatest common factor. And if I factor out an x, I'm left with just x plus 2 over 1. Now I can plug in 0, so 0 plus 2 is 2. So the limit is 2. What's that? What that means, if I was going to look at the graph of this, is there's actually a hole at 0. So the function did not exist, but the limit did because there was a hole. That's what we called removable discontinuity. So factoring, if it's a problem where it looks like you can factor, there's probably a hole in the graph. Let's look at another one. Let's look at the limit as x approaches 4 of x squared minus 6x plus 8 over x minus 4. So first thing, try plugging in the number. If I plug this 4 in, I can tell in my denominator I'm going to get something up here, and 4 minus 4 is over 0. So that doesn't work. So it means I have to do something different. And noticing that this is a squared trinomial, maybe I can factor. So I'm going to factor this. I'm going to make this into two binomials. So x squared is x times x. Factors of 8 that would give me a 6 would be a 2 and a 4, and they would both be minus. Now that I did that, I can factor out the x minus 4, and I'm left with the limit as x approaches 4 of x minus 2. Now I can plug in the 4, so I'm going to take this 4, I'm going to plug it in, so I get 4 minus 2. The limit is also 2. Again, that means there's a hole in the graph at 4, so the function does not exist, but the limit does. Let's try one more with factoring. Let's say we have the limit as x approaches 4 of 4 minus x over x squared minus 16. Again, try plugging in the number. You end up with 0 over 0, which we call indeterminate form. So we need to try something else because that doesn't work. The numerator I can't factor because it's already just a linear term. But the denominator, I'm going to rewrite the numerator. The denominator is what we call the difference of squares from Algebra 2. So it's x minus 4 times x plus 4. And now you notice that these two are almost the same. So what I can do is with my numerator, I can actually factor out a negative 1. So I'm going to change this to be negative 1 times x minus 4. So if I factor out a negative 1, it makes the 4 negative and the x positive. I'm going to keep my denominator. And after I factored out that negative 1, I have an x minus 4 term in both the numerator and denominator that can cancel. So I'm left with the limit as x approaches 4 of negative 1 over x plus 4. Now I plug in my 4 and put 4 in here. So I get negative 1 over 4 plus 4, or negative 1/8. So there's a couple different types of factoring that you can try in Canvas.